Yeah, well, he's gonna get one of the cards tonight.
All right, on the worksheet. A square. What's the order of rotational symmetry of a square? 4. All right. Divide 360 by 4. What's the magnitude? 90. So 90 degrees. So what you're saying is if you had a square, my shape here was a square, every 90 degrees turn that I make, it looks exactly the same as it did originally. A 40gon, a regular 40gon, sorry. What's the order going to be?
40.
40. Do you have to draw it? Do you have to be able to look at it?
No.
No. So 40 times, it's going to look exactly the same. Take 360 divided by 40, you get 9. All right? Don't grab your calculator right away on stuff like that. What's 36 divided by 4? 9. So 360 divided by 40 is going to be 9. So your magnitude would be 9 degrees. In other words, if this shape, and I know it's not, was a 40-sided shape, I would turn it 9 degrees. That's not much of a turn. 9 degrees, and it would look exactly the same. And another 9 degrees, it would look exactly the same. Another 9, exactly the same. Number 3. What's the order going to be on number 3? 2. 360 divided by 2, what's the magnitude? 180. Number 4. Order? 5. 360 divided by 5? 72. 72 degrees. So if this was a 5-sided figure, for every 72 degrees I turn it, it's going to look exactly the same as it did originally. How about number 5?
16.
16, everybody agree with that?
Yeah.
Now, don't get confused on this with lines of symmetry. Because with lines of symmetry, are there 16 lines of symmetry on that shape or on that picture? There'll only be 8. There's like half, right? Because it's a line. So, but when we're doing order of symmetrical rotation, each one of those is going to count. Unlike with lines of symmetry, that one line going all the way up and down only counts once, because it's a line all the way down through there. Be careful on number 6. What's the order on number 6? 3. Why not? Why not 6? It's got to look exactly the same. All right. So the order is 3. What's the magnitude? 120 degrees. 120 degrees, pretty important. A lot of those 72s, real important. There's certain angles that you're going to use over and over and over again. 120, 60, 30. They're like benchmark angles, yeah. 45, 90, 180.
120, 270.
All right. On the homework, open up your books to 472. Questions you want to see worked on 472?
Writing.
I'm just going to look for other people.
Oh my God.
9. Number 9.
Hey, Josh.
Now, with number 9, 10, 11, 12, 13, 14, all you're looking at there, and I'll try to draw this real quick, just to, don't look at my graph here, just look at these lines that I draw up here. I'm not going to change, stupid thing.
Okay.
I'm not going to change colors every time. This one here is red, I'll put an R in it. This one's supposed to be green, I think, isn't it? Then they got another line. And this one's blue. Perfect. What they're trying to show you here, and we talked a little about this last time, if you're just sliding a shape to a certain position, you could also say that, hey, I'm reflecting this shape over this line, then I'm reflecting it again over this line. So there's different compositions you could do to make up a slide or a translation. And that works throughout all these transformations. There's always, somebody looks at this, and I look from R to B here, and I say, oh, I just slid it over to there. But maybe Austin says, no, you didn't slide it over to there. You reflected it over this line, then you reflected it again over that line. It's just a different way of looking at it, all right? Huh?
Said he slid it to the A.
So looking at R to B, this is the main thing they wanted. They did a reflection, then a reflection. Would that work out to be a translation from R to B? Is this shape B the translation of the R shape over here, the red shape? Yeah. That's all they wanted, yes, because if I slid it over there, it would look exactly the same.
That was the exact answer.
How about number 10? Would that one work?
Yes.
Look at it.
Maybe.
Which one did they say? Determine whether the red is a translation enemy to the blue. Yeah, it would work. What did they do? It looks like what did they do to get from the red to the green?
Reflected
They
over
Reflected it over
B.
line B, and then they took the green to get to the blue. What did they do?
Reflected over A.
Reflected it over A. So is the blue one a slide of the red one? Yeah, it looks exactly the same. Other questions?
15? Wait, did we do 15? Yeah, we did.
Problem 15. Graph each figure and its image under the given translation. So they give us P is 2, -4. I'm guessing it's Q, right? Q is 4, 2. Now notice, I'm not going to graph this yet.
You have to graph it, but you just do that fancy thing. where you just-
They said you have to.
Well, they said to graph it, so if they wanted you to graph it, yeah. I'm not really concerned about the graph. Left 3 units and up 4 units. I wish they wouldn't write it that. I guess they want you to see both ways, because about half of, or a couple of these, they did it the old 5th grade way, and then the rest of them, they actually used the rule where they put X + 2, comma, Y - 3 or whatever. So this one they say, let's go ahead and make it a rule. XY is going to go to, what's it say? Left 3 units and up 4 units. So what's going to happen here if I move the X left 3 units? -3. And if I move the Y up 4 units? +4. Very good. So that would be our rule. So what's P prime going to be? What's Q prime going to be?
1/6.
And we could graph those if I wanted to go back to -4. Be right there, that's P. 4, 2. That's Q. Our segment is that segment right there. Change our color here and make it some different color. We'll go with blue. -1, 0. That's P prime. Q prime is 1, 6. 1, 2, 4, 6. Q prime. So that's the translation. That's where we slid that segment to. Slid it from here. Let me do that right here. Slid it from here to there. Other questions?
It's gonna be someone writing testimony questions.
Problem 40.
Asking all the questions.
Copy the figure, draw the reflected image of each figure. See if I can draw this. So they give us, what's the name of this red line here that they have on their paper? M. So line M, remember that's a lowercase m when you put it out there at the end. And it looks, our figure looks something like, yeah, it doesn't look like that crazy line there, that line's not supposed to be there. And we want to reflect it across that line. Now the easiest way, just sort of space it here. You're gonna have to do a lot of this judging on your assignment today. It's gonna be a point there, point somewhere about in there. Judge how far it is from us. Point there. Point straight up here somewhere. Point straight up here somewhere. So our new shape. Wow, that looks terrible.
Yeah, that's pitiful.
Exactly the same.
Point should be like somewhere over here, probably.
Should
Or,
be like right on the line, shouldn't it?
what do you mean? Which one?
In my,
This one?
Yeah.
Like
Because
right
they-
there?
well, cause I saw that was like in line. Okay.
Now, what we're gonna do today, you're gonna rotate this, and just to use this figure here a little bit, you're actually gonna say, all right, if we wanna rotate, you've done rotations before, but they've probably always been around the origin. So it's like you tied a string to the origin and you just move the shape around one way or another, 90 degrees, 180, 360. Well, they're not gonna make it that easy on you. They're gonna say, all right, this point out here, we're gonna rotate this shape around that point. So what you're gonna have to do, and maybe we're not gonna do it 90 degrees this time, they're gonna do it 60 degrees. So you're gonna have to do something like this. Connect that point to the point you're rotating it around, and you wanna go 60 degrees, maybe you wanna go counterclockwise. So we want to go from this point back this way, the same distance, 60 degrees counterclockwise. So that point's gonna, if you don't quit doing that, that point's gonna go right to there. And then you're gonna do the same thing with this one. 60 degrees. And it's gonna end up somewhere over in here, so on and so on. So you're rotating it around a completely different point and 60 degrees, 50 degrees, 40 degrees, 110 degrees. And I'm not gonna go into, because to actually do this, you need tools like a ruler, a protractor, a compass,
Markers.
and all that stuff to actually do it correctly. And we're not gonna go into that much detail. I more want you to see, hey, if I take this and I rotate it 60 degrees, about what it's gonna look like. So you got some idea. Because if you actually had to rotate a figure 60 degrees around a certain point, you probably would have some kind of app on your computer that would let you change that up, right?
Calculators.
There's not many architects out now that are gonna sit and just draw that out by hand. You don't see many, you know, if you ever watched the Brady Bunch, anybody ever seen the Brady Bunch? No.
Too old.
The Brady Bunch, the dad was an architect. Well, he sat at his drafting table and had all these tools that he used to draw everything out. Most architects don't do that now. They use a computer program of some kind to, but I got sidetracked. Other questions?
36.
36. Triangle DEF has vertices. Sketch the image of a glide reflection composed of a translation, and then they give us that translation and a reflection across the y-axis. So somebody help me out and read me the coordinates here in a minute as soon as I get this erased. Go back to red. So what you're doing is you're actually doing a composition here, because we're going to do two things to the same shape. What were the original coordinates they told us?
4-3 for D.
4-3 D.
Yep.
Okay.
2 -2
2 -2.
E.
4-3. 2 -2.
0-1.
Oops, 0-1. Now, the first thing they want us to do to it is to translate it. What was the rule they said to translate it?
X stays the same and Y goes subtracts 2.
So, what's our D prime gonna be? X stays the same, so 4,
1.
1. E prime. Should have changed colors on this.
2 -4.
What, -4?
2 -4. F prime.
0.
-1?
0 -1. No, that's not right.
Yeah, it is.
Is it? Alright, yeah, down 2. Okay.
Don't tell me.
I couldn't see my number. So this is our red shape. Let's change the color here. Make it blue again. This right here should all be in blue, not red. So 4-1. D prime. 2 -4. D prime. And 0 -1. F prime. So that's where we slid it to, or we translated it to. Then the next one said to go across what, the y-axis?
Yeah.
Let's do that in, we'll do green. So if you're gonna reflect it across the y-axis, your rule for reflecting across the y-axis is x, y goes to what? Negative x, positive y. So if we came back over here, D double prime is going to be -4, 1. E double prime is going to be 2, oops, that's -2, -4, and F double prime is going to be, this is confusing me because the marker's not writing at the same time I'm drawing on the board. F double prime is just going to be 0, -1. So what's going to happen with F double prime? I'll stay right there. That's F double prime, -2, -4, E double prime, and then -4. Is that a positive one? Can't see it. Yeah. That's D double prime, our new shape, something like that. So you have your original shape is the red, the translation, the slide was the blue one, then we reflected it to get the green one. That's our composition. We did two things, two transformations to the same shape. Other questions?
39.
39?
Yeah, maybe slow.
39, find the slope slope of a line through these 2 points. Mr. A was just over here hollering at me the other day. He's not gonna do it when you guys get to him, right? He was hollering at me because he can go holler at Peyton's dad as far as slopes go, because that's something that you should have learned in algebra.
I don't know, but I met that dude's brother, because we were running a fundraiser at Highland Golf Course, and he came out and told me to tell him that he was short, and
Sure
I know
was
what
his
to say.
brother.
Yeah, I mean, Isaac Gordon.
Problem 39. They give us -2, 5 and 2, -1. They want us to find the slope of that line. Now, could you graph these 2 points and find the slope?
Okay.
Got a point there, line goes through it. Could you graph it and find the slope? What's another name for slope? The layman's term that Mr. Harrison or some other math teacher down there probably taught you.
Slanted line.
Something over something, rise over run. So you could do the rise over run. You could say, all right, I rise this much, I run that much, and come up with it.
That's slanted.
All right. Hopefully, if you're given 2 points, you don't have to draw a graph and do that because that takes too much time. Your slope formula, not slope-intercept form of a linear equation, that's y equals mx plus b. Your slope formula is that. You subtract the y's on top, subtract the x's on bottom. So on top I got 5 minus a negative 1. X is on bottom, negative 2 minus 2. Now here's where you got to be careful because we've done the midpoint formula and the distance formula, and the order we took the points didn't make any difference. With the slope formula, it makes a difference. If I started here and did 5 minus that negative 1, then that means I got to start back over here and do the negative 2 minus 2. You can't flop them around. This changes to plus. What is 5 plus 1? Negative 2 minus 2. Don't grab your calculator because you don't, for slope, you don't want a decimal form. You just want to reduce this down. What will go into both 6 and negative 4?
2.
2 will go to 6 3 times. 2 will go to negative 4, negative 2 times. So our slope tells us that we go up 3 and to the left 2 every time. Up 3 to left 2. So if I come back over here and I go up 3, 1, 2, 3, to left 2, I should end up right back on the line. Up 3 to left 2, I should end up right back on the line. Or I could go down 3 into the right 2, and I should end up right back on the line. It's pretty good that time I actually drew it straight. So what I started to say, Mr. A came over and he just gave a quiz or something in Algebra 2, and they had to find the slope using 2 points. And he said about 60% of them didn't have a clue. They just left them blank, couldn't find the slope given 2 points. That won't be you guys, all right?
Yeah.
Totally, probably me.
All right, today is the 23rd.
You still gonna record this?
Go ahead and copy this down. What we're going to cover today, rotating images. So we want to rotate things. A lot of them will be 90 degrees, 180 degrees, 360 degrees, clockwise or counterclockwise. We're going to have rules for each of those. Now, what's the rule for 360 degree? A rotation of 360 degrees is going to be? It's going to be the exact same. It just goes right around all the way back to where it started at. How about for 180 degrees? With 180 degrees, do we have to worry about clockwise and counterclockwise? Do I need to draw a little clock up here so that you guys can see that going around this way is clockwise? Going around the other direction is what? Counterclockwise. I know most of you probably, maybe your mom has that one nice looking clock in the house that actually still has a face on it instead of a digital. But probably most of you in your bedrooms, you don't have that clock.
What's wrong with that?
It's
Digital is so much easier to read.
Huh?
You won't have to be like, let's see, that one's 5, and we'll Three kind of sad, so
Also, be able to rotate images using any angle of rotation and any center. I should put that on here also. And any center of rotation. Those are gonna be the more difficult ones. The others, you guys are intelligent enough that you can follow the rule and get all that. It's when you start putting it out somewhere else. If I'm on a graph, and I say, rotate this figure about that point right there, 60 degrees. Well, I can't give you a rule for every single point on the coordinate system and what's going to happen for every degree, because we'd be here for the next 20 years trying to write all of it down. All right, so that's where you'd actually have to use a protractor and a ruler and go through all that. And we're just going to sort of estimate it. We're going to say, all right, that point we're going to rotate it about that, so this is going to come out here somewhere and it's going to be right about there. This point's that far, so it's going to come out this way a little bit, it's going to be right about there, and we're going to rotate it using our brains, using our imagination. Identify rotational symmetry and find the order and magnitudes. That's what we did with that beginning worksheet. Nothing real difficult there. Remember, order is how many times in a whole turn that shape looks exactly the same. And then to find magnitude, that's how many degrees each of those times stops the shape to look the same. And all you do for magnitude is take 360 divided by the order. You want to move over here so you can put your hands up?
Oh, no.
Sure. Yeah, it's right there.
writing glove.
That is rotations.
Are going to want to jot down some things there in your notes. He's going to go over some rules and maybe a couple of definitions that I'm not going to put up here. So just watch and write down what you think is important.
Rotation. Now this one, like the first two, like translations and like reflections, after you perform the transformation, it produces a new figure exactly like the original. So there should be congruent. Another name for rotation is a turn. Primary rotation, a figure is rotated or turned about a given point. That's very important. It's turned about a given point. So kind of like you ever watch a CD spin in a CD player, that CD is being rotated about that center thing that pops up, spins about the given point. The majority of our rotations we will concentrate on, the center of rotation will be the coordinate 0, 0.
That's not true for us.
A complete turn is 360 degrees. Why would that be? Complete turn.
It's a circle.
360 degrees in a circle, right? A half turn 180 and a quarter turn is 90. A rotation is.
You have to write those three things down. You don't have to write down everything he's got. Three important things:
The center of rotation.
center of rotation, angle of rotation, and the direction.
Usually it'll be 0,
Maybe
0.
just those three: center,
We need to
angle,
know the
direction.
amount of the turn expresses a fractional part of a whole, right? So if it's a 180, what else could I call it? Rotation of a half. If it's 90, we could call it a quarter turn.
What would a 60-degree turn be?
Or is the angle of degrees,
A 60
angle of
degree turn.
rotation in degrees. This is
What
we
fraction?
commonly use. Angle of rotation.
60 out of 360 is 6.
Then the third thing we need to know is the direction of rotation, clockwise or counterclockwise. Which is sometimes the topic of great frustration among students. And I'll see them sit there and look up and start moving their fingers, which will work. However, I want to point out
like this.
something that you can use in your environment.
Not just moving their thing.
I know, like,
Something over there, that square thing with the
Right inside, right?
with the hands. That's what clocks used to look like before they were digital, right? I know laugh, but some people.
So he's making fun of all of you because you don't know what a regular clock looks like.
I know
Unless
what
you
a
had
regular
Mr.
clock-
Watson for class at some point. And
That is a clock.
We all had to have Mr. Walker.
he
That's the
he
most
puts
flashy
that
one I know, but see the little red hand there?
paper over his digital clock.
The way she turns it up and down, yes, you see it, okay. See the way the red hand is going? That's clockwise, which means the other way is counterclockwise. So if you forget, use your contextual clues, your environment. I won't say don't look at the clock.
Sorry, I forgot my clock today. I was gonna bring in a clock so I could
That way
be
is
able to
clockwise.
demonstrate as he's going through that.
Why don't people know which way a clock goes? That's
That
horrible.
has,
I think it's annoying that people have to count by, and it's like, I know
I
it's
forgot
by looking
in
at it.
Spanish when we were doing the words. I forgot that it was like 5:10. I was like, why am I getting all these?
Yeah, you should know that. It seems like you shouldn't have to.
now, these rules are specifically for those about 0, 0. When the center of rotation is 0, 0. However, like I said, the majority of cases we will have that show the center of rotation.
All right, this is what you need to write down for sure. I'm gonna stop it here in a second.
I spin.
Write each one of these down. Make sure you write them down correctly. I looked at somebody's notes first block,
The new coordinates.
and they had them written down all wrong. I thought, how in the world?
Right, that's a reflection, sorry.
So if you're going 90 degrees clockwise, all of these are about the origin. Where's the origin again?
0, 0.
0, 0. So all of them are about the origin. 90 degrees clockwise, and for each one, I'm just going to write a little two-step thing up here at the bottom to help you remember what to do. You're going to flip the two numbers, and second number is opposite. So you flip the two numbers, and the second one becomes the opposite. Now, do I expect you to have these memorized? He's going to say here in a minute, make sure you have all these memorized. I don't expect you to have all these memorized. Is there ever going to come a time in your life when you're out doing your job and your boss says, you can't use that computer, you can't look anything up to try to figure this out? No, they're going to let you look things
Where
up.
does this apply?
So,
I mean,
Honestly.
unless someone like an architect or something, I'm pretty sure finding the area of a circle.
how do you think you like all those silly games you tell me you're putting them on your calculator and stuff? How do you think they make those
I
games?
haven't put any
You-
games on my
you-
calculator.
You don't think that the people who create those games have to use this kind of stuff?
No, they use programming, and programming is like coordinates, not rotations.
So when
It's
so
somewhat
so
related, but
so
that's
when
not what I want to do.
so when
in life.
when you're playing a game and the guy's walking, you don't think they're doing a translation on those points?
No.
And then when it's Sonic the
Well,
Hedgehog
it's
and
somebody-
he starts rolling, you don't think he's doing a reflection or a rotation?
No, you don't write that in a program.
Yes, you
It's
do.
Like, I don't.
Yes, you do.
Have you programmed?
Yes.
You programmed a calculator, not
No,
Sonic.
that's what you gotta do to do any of this stuff. Even,
Well, as long as
what's
somebody
what's the real dumb game where it's just all blocks?
Minecraft.
Minecraft.
Oh, gee.
Minecraft, even on Minecraft, as simple as those guys made that game, and they made it simple to make it easier for them, you don't think that they have to do
Well, if somebody else
rotations
is
and
doing it,
reflections?
I don't care about it. I mean, I'm just gonna buy their game and play it.
I'm ignoring you again, Brian. All right, listen.
The original package, now your new Y, you're changing time. What's happening is if it's 90 degrees clockwise, if it's in the first quadrant, it's going to the second quadrant, which means your Y coordinate is going from positive to negative. Your new Y is going to be negative. The next rule. 90 degrees counterclockwise, so this is going that way from like quadrant 1 to quadrant 4. You'll change their places, so the Y will become the X will become the Y, and your new X, the old Y, becomes negative when you change its sign. Now realize you change the sign. That doesn't mean it's always negative, because if you start with a negative one, it's going to make it positive. The next one is 180 degrees clockwise or counterclockwise. Why would it be both?
Because 180 is just a line.
Yeah. Halfway is halfway. Doesn't matter which way you go, 180 degrees, you're forming a semicircle, so that's halfway around. And what you do is the coordinates stay in the same place, you just change their signs.
That's
It's
one
like
that I
the
have.
like super fun. She's always like, yeah, and then I did the Ricky line.
And we have one more, and this is my favorite rotation personally, and usually it's students' favorite rotation. What's that? 360, why is everybody's favorite rotation?
Because bananas.
That's doing it. That's right.
Yep.
That's right.
Nothing changes, why? Because you finish where you started.
I don't know why.
It's one complete revolution.
Oh, thank you.
Brian, relax, alright?
Oh, it's fun.
Brian's
Yes, you will
starting to
have
get
at
annoying.
least one of these on your own.
Oh, need homework over this?
Alright, why is my pen not open?
Holy crap, this video is 28 minutes long.
Oh, this teacher like recorded just like you are if you put it on YouTube.
Problem.
No, he puts it on teacher too. Teacher difference. One has cats there. What? What color was that?
Today we're going to do a third type of transformation. That
I love it.
We have cantaloupe and watermelon in our garden.
What?
So I had Dylan over yesterday and it's a big
Float the duck in the water.
And we
And
went,
it goes down.
we picked the watermelon and the cantaloupe.
What is the matter with him? Did he get in trouble? Or was everyone like, what's
today we're going to do a
that?
30 degrees. You're forming a semicircle, so that's halfway around.
I wouldn't
And
do
what you
it.
do is the coordinates stay in the same place, you just change their.
Alright, so on this one, because I was doing something else and got lost for a second. 90 degrees counterclockwise. Flip them around. And instead of the second number, taking the opposite of the second number, you take the opposite of the first number. First number is the opposite. Don't think negative, because if you think negative, and it's already a negative, then you're going to forget to change it. It has to become a positive. 180 degrees, clockwise or counterclockwise, and he already talked about this. No, doesn't matter if you go clockwise or counterclockwise with 180 degrees, you end up in the same spot. On this one, numbers stay in the same order. So same order. And you take the opposite of both. Opposite of both numbers. Just trying to give you a way that you can think about it, and that'll help you remember. Then 360, he already talked about 360, and I'm going to have him put it up here, then I'm going to skip through it a little bit.
And we have one more, and this is my favorite rotation personally, And usually it's students' favorite rotation, what is it?
360.
What's that?
360.
360,
That
what
was
is
so
everybody's favorite rotation?
Didn't do anything.
It's fun.
You don't have to do anything. Nothing changes, why? Because you just finish where you start. It's one complete revolution.
Ooh.
Straight hold this circle, and make a circle that way.
Let's go over
That's
this.
what happens.
Alright, watch as he goes through this.
The spinning thing. It's called a compass.
Spinning thing. That sounds like Brian.
What?
Alright, this
We're gonna start calling you Marcus.
rotation, it's like that.
Because the guy on here, Marcus,
What's gonna happen?
said, he said, you know that spinning thing that you use, you could make a circle with that.
My original
You need to
cue
force
is
this.
at 2,
You're not Marcus?
Nick, I will destroy you. My bare hands. Did you take the Google?
4.
Drop down to you pretty straight.
Notice on this, and I know I skipped through a bunch of it, but what's the first thing he did before he ever even went over there and drew that?
Use the spinning thing.
What did he come over here and do first?
Mark out the coordinates.
coordinates.
The new coordinates of the image. He didn't graph the pre-image, he didn't start graphing anything, he found the coordinates of the new image first. And this is what you're gonna have to do. Then he went over and graphed both of them at the same time.
You create a shirt from onion smells.
Does it right? Good, it should be upside down. It's in the right place, it's rotated 180 degrees. And one way to check it is to make sure all are on prime are equidistant from the origin. B prime.
Notice, watch what he's doing. 90 degrees
B
clockwise.
prime is at 1
What's 90 degrees clockwise do?
Right, the original is A,
Switches X and Y and makes the second one the opposite.
To make the X.
kind of triangle is good for.
Right triangle this time.
Everybody shout right triangle at once, okay? It's a right triangle.
Again, notice he found all his coordinates first. Now he's graphing the pre-image. Now he's gonna graph the image as soon as his students quit complaining at him because his line was crooked there.
We don't ever do
Wait, you
that.
did this in class? You did this in class?
No?
No, we just asking questions. What?
He's relating this to us.
Spare time. Today, he does it at home.
Josh, that's around.
Sunlight.
Right, A prime, now what should this look like when it's done? 90 degrees.
Where should it be? What quadrant should it be in? If you go 90 degrees clockwise.
Quadrant.
Quadrant 4, bottom right.
Right, I like to visualize that.
Get that in your head before you actually do it to make sure that you don't graph something wrong or make a little mistake.
A prime is at 1, 2, 3, negative 1. B prime is at 1, negative 5.
Put yours on YouTube.
Some of them are from last
C
year
prime is at
Oh,
1, negative
I thought he was gonna put us on
Especially
YouTube.
today's talking about video games.
I got to, gotta go back and know how to do it again.
Oh, I forgot like 40 things.
That's what happened. Down.
Yeah, because he doesn't
See, I
have
think
class for you.
that was the problem, is that a lot of them were too long and,
Well, now YouTube allows more than 15 minutes in.
well, you can, it did last year too, it just takes a while.
We could also use the
You gotta have
words, given
special-
something
you
like
gotta
this
go
to
into
figure out this
special.
original, correct?
Permission.
How would we do that? If we're given the coordinates after the rotation, how can we figure out the original coordinates? Yeah, reverse the rule, right? Exactly. Cool.
All right, I'm gonna pause this because we're gonna go ahead and do this. What they're telling you here, you got a 90 degrees clockwise rotation about 0, 0. They're telling you, and I'm not sure why they gave you A, B, C, and D, because if this is the new shape, this shouldn't just be A, it should be what?
A prime.
A prime.
B prime. C prime. B prime.
All right, so those should be primes in there because this is the second shape and they want to know where did the shape start from originally. So they want us to go sort of backwards. What's the rule for rotating 90 degrees clockwise? A 90 degrees clockwise.
Flip them and then negative, second negative.
Second one's negative, so you flip them around, and that second coordinate becomes the opposite. So what's the original A gonna be? 0, 0 still. If you're rotating around the origin, is that point, if it is the origin, ever gonna move? No, it just stays right there. What's the, oops, not A prime, these are the originals. What's the B gonna be? If we flip them around, so you got
Two negative.
2,
Oh, yeah.
-2, what's gonna happen to the second one? Make it a positive, because you do the opposite, right? Is that right? C. Flip them around. Does that say, what's that say? I can't remember. -4, is that what it says?
Yeah.
So we flip it around, and it's 4, -4, but what do you do to the second one? Opposite, so it's a positive. D. -4, 2, we flip them around. And we gotta do the opposite of the second one. So -4, -2. So we use the rule, and all we're doing, hold on now, did I do that right? Did I mess it up? I think I messed it up. Somebody's gotta stop me before I do stupid stuff. So we're using this rule, but we're going backwards this time. No, we don't. So we want, what we did was we flipped them, and we did the opposite of the second one, but we want to undo that. So we want to reflip them and take the opposite for the first one. That was just ignorance. 0, 0, that's not going to change. Now that I've confused you all, what's this one? If we flip them,
-2, -2.
there you go, then I think that's what Peyton said originally, and then I told him he was wrong. -4, 4, we flip them.
4 negative.
What?
-4 negative.
-4, -4.
-2 negative.
With these, do the opposite of the thing, because we're doing it in reverse. So those are our original points. I confused you to death, Austin, because I did it wrong. That's what happens when you get in a hurry and you don't pay attention. So that's all he's trying to get you to see here, and that's a lot of what we're gonna be doing. They're not gonna just ask you to rotate it 90 degrees all the time like you did back in 5th grade or 6th grade or wherever it was. They're gonna wanna know, hey, can you actually do something else with this? Can you work it backwards? Can you do a composition where you do something twice and so on and so on.
Large mechanical shovel is used to move metal. If the coordinates of the shovel are A00, would be -2.
Those points look like the ones we got.
What's the rule for 90 degrees counterclockwise? The opposite one though, right? Because those are opposite rotations. So that's what they're really are.
Now, let me back this up a little bit because I want you to see this. I want to back up one. Oh well. This is what we're going to do some of. They gave you these two shapes. And you see what he's done? He's sort of drawn lines or part of circles in to see where it's moved to. Instead of being on the grid, it's going to just be something out like that. And you got to tell them how much did you turn it and which direction did you go.
Start here, just end up right here.
And they're going to want to know where the center of rotation is.
Starting there, right? This line, and you're ending up right there.
Now what he's saying here, maybe an easy way to look at it. This is our first one. How do I know that this is the first shape, the original shape, and this is the second one? You can't hardly see it now since he drew all that on there, but they got the little primes on it. So, you know that this is your this is your original, this is your image. If we look at this segment right here, it's going to match up to this segment, the ones that he traced in purple there. Well, this segment went to here. What kind of angle do those two form together? 90 degrees. So what degree of a turn did they make with this shape? 90 degrees. Was it clockwise or counterclockwise? Counterclockwise. And he's not going to figure out where the center of rotation is, but you sort of need to be able to see that the center of rotation is going to be somewhere in there, and it's rotating around that. And sort of the way you can figure it out, if this is, what is that, Z? I can't hardly see it. Z to Z, that center of rotation is going to be somewhere where this segment is the same length as this segment, so it's probably actually over here a little farther. From here is the same as from here to there.
So it's a 90 degree, and which way is it?
All right, just a couple more definitions. These are the rotational symmetry that we did at the start. While you're writing that down, I'm going to pass out a little worksheet that we're going to talk about. Order and magnitude, make sure you know how to do each one of those. Remember, order, you just count the number. How many times that shape looks exactly the same, and you always start with 1. The first time is 1, second time looks exactly the same, 2, so on, so on, so on. Look at this snowflake picture up here. What's the order of that snowflake picture? 6. How do you find its magnitude? 360 divided by 6, what's that give you? 60. So order is 6, magnitude 60 degrees. The second picture, get rid of those dots over there on the side. What's the order of that one? How many times? That you're doing the magnitude. 2, and then so the order is 2. The magnitude is 180 degrees. How about the cow? What's the order on it?
360.
1, and then the magnitude is 360.
What the heck is that blue thing, Ice Cube?
It's an old TV screen. How about the band over there? What's its order going to be? 2, and what's its magnitude? 1/8.
Oh, I thought that was
Do I?
No, Peyton, this is just bring it in tomorrow.
No, that's not the whole one. All right, on the worksheet. Looking at the worksheet, we're just going to run through some things real quickly. We only got like 9 minutes. We're going to run through a couple. Remember to use your rules. So if you're doing 90, 180, clockwise, counterclockwise, whatever. The other thing I will say, if I'm looking at number 2 here, and I'm confused about how it's working, and it wants me to go 180 degrees rotation, do this with your paper. If I want to rotate that 180 degrees, how much am I gonna turn my paper? It's gonna be upside down. So that's what it should look like when you read graphics. If that helps you, do that with your paper. When it comes test time and we're doing this, and I see you sitting there turning your test around like this, I'm gonna think, you're probably gonna see me smiling because I'm gonna think, hey, that's what you should do. Use your brain a little bit. Alright? What if they wanted, let's say, number 3, what if they wanted to go 90 degrees clockwise? How much should I turn? Just a quarter of a turn. Alright? Flip over to the back side.
Wait,
Yeah.
when you rotate it over the origin 180 degrees, is it like reflecting it over the axis?
It depends. Depends where the shape's located at originally. So I don't want to say yes it is because
This one.
depending on where the shape's at, it could be. Look at number 7. They're asking you to describe the rule. Now, it rotated around the origin. We know that. Now we got to figure out 90 degrees, 180 degrees, 360 degrees, clockwise or counterclockwise. Pick a point on the original shape. Somebody pick me a point on the original shape. P. So everybody put their finger on P. Number 7. Put your pencil on P, and now go around till you get to P prime. How much of a turn did you make?
It depends which way you go.
Alright, 90 degrees clockwise, or, what Brian said is true, what's the other thing you could do?
Go 270.
270 degrees counterclockwise. Either one of those would work. Now, how come I didn't put rules up here for 270 degrees? Or he
You don't
didn't?
want to do that.
Could do it, you just said to do it.
No,
It's just a 90
It's a 90-degree turn the opposite way. Okay, so if they tell you to go 270 degrees clockwise, then that's the same as going 90 degrees counterclockwise. So you could use that rule. Look at number 8. Pick a point in the original shape on number 8.
Hey,
A. So we take A from where it's at. Brian's not going to have the comment this time because what kind of turn did they make? 180 degrees. Clockwise or counterclockwise? It doesn't make any difference. So be able to come up with those rules. Look at number 9. What degree of turn did they make?
90.
90 degrees. Clockwise or counterclockwise?
Clockwise.
Clockwise. Which one is it? It's counterclockwise, isn't it?
No, it's clockwise.
It's counter.
How? Because if you put your pencil on N, and then you go 90 degrees.
No, you're on, you put your
You're on
pencil on the
in
wrong
front.
one. You're on in front. N's at the very top.
Stupid.
Yeah, it's hard to see because they do the line right over the top of it. Alright, flip over to the back page. On the back page, and I'm just going to draw this really, really quick. We don't have a whole lot of time. If I draw this shape up here, my shape is going to be perfect, just like always. This time, they want us to rotate this 90 degrees about the point -1, -5. -1, -5 is going to fall somewhere like right in there. This is where it's going to get hard. And on the homework next time, the homework assignment's sort of long. and I'm not gonna throw a big fit next time. If you don't get it all completely, I want you to come in and ask questions, make sure you understood it. This is where a lot of new stuff that we're introducing. What you're gonna do is you got all these orange points. This is the point, this is your center now instead of 0, 0. And that makes it a whole lot more difficult because you don't have a rule for it. All you're gonna do, you wanna go 90 degrees. So if I connect this point out here to that, does everybody see the length of that segment? And I want it to go 90 degrees, what'd they say, 90 degrees clockwise. So we're going, our turn's going this way. Well, what I want then is this to come up here, that same distance, which you'd need a ruler for if you're going to do it exact. I don't want you to do it exact because you also need a protractor because my angle there doesn't look like it's 90 degrees. It looks like it's too much, doesn't it? Gonna come up something like that. Go that same distance and at a 90-degree angle right there, and that's your new point. So this point's going to move right to there. When we do this point, see how far it is from there? We want it to go 90 degrees, somewhere about in there. So this point's going to move right to there. This point, we connect it to that. Go 90 degrees clockwise. Make a 90-degree angle down here. Make these two segments about the same length. This point's going to move down to there. We connect all those. Everybody sort of see that? That's our new triangle. Rotating it 90 degrees clockwise about that crazy point that they gave us. All right?
We have to get packages.
No. All you guys do is this assignment here, packet, just for us to use to go over a couple of things. I know that, again, this is going to be the hard part, being able to picture that. You need a protractor and a ruler if you were going to do it exact. I'm not concerned with that. I'm not going to make you sit there and measure on a little piece of paper a 60-degree turn. Just think, all right, 60 degrees, this is about 45, and then 60 is going to be about like this, and sort of estimate it. See if you can imagine that in your head, what it's going to look like, a 110-degree turn or whatever.